introduction and let people join in. Still some people are connecting. So we are going to record this Protect Open webinar. And Aimée, Slangen and Gonéri Cozannet gently accepted to give an overview on what is new regarding sea level rise in the sixth assessment report by the IPCC. We roughly have 1 hour in front of us, something like 45-50 minutes for the presentation. And we will keep the discussion as long as people want to discuss and have time for. So please, Aimée, I think you are going to start. Logical. Working group 1 first, working group 2 next. The floor is yours. Share your slides. Thanks again for accepting to give that talk.
So let's see. Do you see the presentation okay?
Yes, absolutely. It's fine.
Okay, good. Yeah, so I'm gonna try and keep it in 20 minutes. And I should probably mention that my son is sick at home. So if you all of a sudden hear someone shouting, "The movie has stopped," then you know why. I will discuss today what's new in the AS6 report for Working Group 1, and after me, Gonéri will talk about Working Group 2. So maybe a brief introduction. I suspect most of you won't need it, but just in case. And this, well, this presentation is recorded as well, so it might be good to briefly recall what the IPCC actually is and what it does. Well, so it's the United Nations body for assessing the science related to climate change. It's really about assessment and not about doing new science necessarily. So it's looking at the whole body of literature that's around, of all the science, and then aimed at providing policymakers with all the knowledge that's there on climate change, with the knowledge on impacts, on potential risks, and also on how can we adapt and how can we prevent more changes from happening. So this is divided, the IPCC is divided in working groups. We've had working group 1, the physical science basis, which I will talk about today. Then working group 2 on impacts, adaptation, and vulnerability. Gonéri will talk about that. And then there was working group 3, the mitigation of climate change, and that report appeared in March of this year. So all of these reports have appeared between past August and March. And coming September, there will be a synthesis report coming out where all of these reports, which each are probably about 2,000 pages, will be synthesized in one 10-pager in a summary for policymakers. So you can imagine there's quite a challenge for the people writing this summary for policymakers. So I was a lead author on chapter 9 on ocean crisis and sea level change. Well, we had this amazing team of authors, some of whom are in the audience today. I saw Tamsin coming in. So we had 3 coordinating lead authors. Those are the ones in green, Baylor, Helene, and Kunde. And then we had 3 review editors, Uni, Benjamin, and Simon, who basically looked at how we responded to all the review comments and if we did a good job in responding to all of the comments. Because as you know, the IPCC is open for review for experts and government. And as authors, we need to respond to comments coming in after these reviews. And we had a lot of comments, I think, for the sea level section, the first time around about 200 and the second time 500 comments. So it was quite a lot of comments, and it's not comparable to any other review you've probably done in your scientific careers. So yeah, it was an amazing team to work with, people from all over the world and people with all kinds of expertises as well. And it's thanks to all of them as well that I'm presenting today. So when we go to sea level, I always tend to see sea level as a kind of a thermometer of climate change, because there's so many processes that come together in such a simple thing as the top level of the ocean, basically. It's changes happening inside the ocean, so ocean warming, which causes steric expansion. There's differences in the currents as a result of, for instance, wind-driven changes. There's changes happening on the ice sheet, something we're studying, of course, within Protect. what's happening on Antarctica, what's happening on Greenland, what's happening in the glaciers. And there's things happening, the amount of land water storage is changing as well. So all of these processes are coming together, and we try to, well, first we look at the observations of sea level change and try to explain what we've observed, but we also try to model all of these processes to make sea level projections going into the future, of course. So if we look towards the past, then what was new in this IPCC report is that back to 1971, we could actually very well explain what's been observed in total. So in this graph on the left, you see a dashed line, the black dashed line, which represents the total global mean observed sea level rise. And then all the different colors represent the different processes contributing to sea level rise. So in bluish colors, you see the ocean changes. So that's mainly ocean warming. In grayish colors, you see the ice contributions to sea level rise. And then in brown, the land water storage. And you can see that this adds up really very well for this period. It's not yet a completely accurate, complete closure, but it's as good as you can, well, as you could wish for, basically, given that observations not necessarily have a great quality if you go back further in time. Now, if you focus on the table on the right, we can also see that the global mean sea level is accelerating. So if we look over the entire 20th century since 1900, the total change has 1.7 millimeters per year. Now, if we come closer to the past, so for this 1971 period, it's about 11 centimeters. So the rate is increasing as well. And if we go to the latest periods, which is 2006 to 2018, we have a rate of about 3.7 millimeters per year. So the sea level rise is increasing. Now, if we turn to the projection, so we have quite a good grip now on the observations. How did we make the sea level projections for AR6? Because this is a change from AR5. And I suppose the most important change is that they're now consistent with the AR6 assessment of equilibrium climate sensitivity. So within this IPCC report, there's also an assessment of what's the best equilibrium climate sensitivity. And we've made sure that these projections, the sea level projections, they are consistent with that assessment. And we did that by using emulators mainly. And if there's any questions on emulators, I will redirect those to Tamsin because she is the chief of the emulators. She's smiling there. Tamsin has written a beautiful paper as well on the ice sheet and glacier contributions and how emulators can be used to make projections with that. Also new in the AR6 is that we represented a deep uncertainty by making low confidence projections. So we have all the processes that we have quite good confidence in with medium confidence processes. Those are our sort of mainstream projections. But then on top of that, we've also made low confidence projections, which have, which lead to quite different values, as you will see in a bit. For the projections up to 2300, we don't do model projections really, but it's more a literature assessment. So we really look at the numbers coming out of the literature for all the different contributions and how that leads to sea level projections in the year 2300. So how did we do this? How did we make those projections? Well, we use FACTS, which is the framework for analyzing changes to sea level. It's a framework developed mainly by Greg Garner and Bob Kopp at Rutgers. Greg was one of the chapter scientists alongside Tim Hermans, who worked on our chapter, and Bob Kopp was, together with me, leading the sea level section of the AR6. And what FACTS basically is that it you have all kinds of modules. So for every contribution to sea level rise, so for instance, for thermal expansion, there's a module for Antarctica, there's a module for Greenland. And what you can do is the idea is that that everyone can set up this framework and exchange any module for another module. So if you have a different ice sheet model, you can replace the AR6 projections for Antarctica, for instance, by your own model assessment and insert this into this fact framework. All of the data and the framework is now available on Zenodo. I've pasted the links here. And you can also find them if you on Zenodo search for AR6 sea level projections. You will find these records. So FACTS is basically the framework, but going into this is a lot of data from CMIP6 models, so the climate model into comparison project. And these CMIP6 simulations, they run based on different scenarios. And the whole IPCC AR6 basically works with scenarios. So there's a lot of what if scenarios. What if the CO2 emissions are reduced to net zero by the year 2050? Then you get this light blue line on the left, which translates to a sea level, to a temperature change of about 1.5 degrees at the end of the century. What if the CO2 emissions are doubled by the year 2050? Then you get this upper red line. So that's a heavy warming scenario. Then we get to about 4.5 degrees of sea level rise. And all of these different colors you see here, you will see them coming back because we've also computed the sea level projections for these different scenarios. So if we look to the year 2050, you basically don't see any differentiation in the different colors between all of these different emission scenarios. So you can see the light blue line and the red line, but they are really close together. So it's about 18 centimeters for the Paris Agreement and about 22 centimeters for a sort of an average scenario where we continue emitting greenhouse gases, but maybe don't increase the emissions. Now, if we go to the year 2100, there starts to be a bit more differences between the different scenarios. So for a Paris type agreement scenario, we get to about 40 centimeters. If the emissions increase, you get to 70 centimeters, and it could even be 80 centimeters if we have this doubling of the CO2 emissions. And you can see how it is going into the future is going up, diverging more and more. So a new thing for the IPCC is also that we now provide projections to the year 2150, because 2100 was getting really close. And we did have the opportunity to go beyond 2100. So for policy relevance and just to have a bit more future outlook, we extended those projections to the year 2150. Now you can also see the dashed lines, and those are those low confidence projections I was talking about. So this dashed line on the top is representing the 83rd percentile and the 95th percentile of those low confidence projections. So those are really the extremes of the extreme scenarios. And there you can see that you'll get into even already 1.5 to 2 meters in the year 2100. And this is rapidly increasing in the years after that. And there's a lot of people within Protect that can talk a lot about why this is, why there's some tipping points, potential tipping points in the ice sheets, what's happening, what kind of processes there are. So I won't go into detail too much there now. So just to sort of summarize, if we go look on the shorter term, there's really not that much divergence between the different scenarios yet. If you go to 2050, it's also all really close together still. So about 20 centimeters in 2050 is what we'll get. Doesn't really depend on which scenario we're talking about, but this scenario starts to matter the further we go into the future. And if you look at the year 2150, then there's really a marked difference between having a Paris type scenario and well, for instance, following this low confidence scenario, there's really big differences in how much sea level rise that brings. So what's also new in the AR6 and is that we made the projections by warming level. So by sort of reorganizing the projections from these different scenarios, you can also make projections by temperature levels. There are some caveats to this, which make it difficult to go very far into the future, but we've made the projections at least until 2100. So here are some ideas. So if you follow a 1.5 degrees, so that's about Paris, maybe a little, then you get about 44 centimeters. And this goes up to 5 degrees warming by the end of 2100. Unfortunately, I don't have a pretty picture of this. It would be nice actually to have a figure of this, so maybe I should consider making one. But I briefly wanted to mention it because it is one of the new things we've done in this report. Now moving more towards the regional projections, because of course, well, it's really important what's happening on a global average scale, but what's happening at your own local coast is probably even more tangible and also more important for the things. For instance, Gonéri is going to talk about the impacts. Then you want to know what's happening regionally. And what we see if we look at these regional patterns is well, that global mean sea of that the regional mean sea level will continue to rise throughout the 21st century in most places, and that for about 2/3 of the coastline we find that sea level rise is within about 20% of the global mean increase. So it's close to the global mean, but it can be 20% more, and it can also be 20% less. So it's still quite important to look at what's happening at each coastline and why those differences are there. So there's all these different processes working together, and depending where you are on Earth, these processes matter. If we look further beyond 2100, we see that global mean sea level will continue to rise for centuries due to this continuing deep ocean heat uptake and also mass loss of the ice sheets, because the deep ocean and the ice sheets are simply not in balance with the current climate yet. And that's not even taking into account future changes of the climate. So this is something we know is coming. We do have some impact on how fast this is going to go, especially reducing the greenhouse gas emissions. We see, for instance, under a Paris Agreement that you can sort of reduce the speed of the rise already by 2100. So there you can see that a Paris type would be about 4 millimeters per year, whereas if we continue on the current path, you'd have about 10 millimeters per year. And if this whole, well, if everything goes wrong in the ice sheet, you could even go up to 60 millimeters per year. So there's still choices to be made, well, today that will matter for sea level for centuries to come, basically. Now, on top of that, well, the main risk of sea level change is maybe not necessarily in the mean change, but more in how this mean change increases the frequency of extremes. And this figure you see here was made by the SROC report, which is the previous IPCC special report on oceans and the cryosphere. And that shows really nicely how a 1 century sea level rise, sea level extreme may turn into a once a year sea level extreme. So that means that a water height that you see only once a century now, at the end of the century, you might see it yearly. And that's only because of mean sea level rise, but there might also be still differences in winds, for instance, which might even change this further. And if we combine the statistics of the extremes with the sea level projections, and then we see that about 90 to 30% of the tide gauges by 2050, you will already see a once a century event has turned into an annual event. And at the end of the century, this is even more. So about 60 to 82% of the tide gauge locations by 2100 will then annually experience what's now a 1 in a century event. Another new thing of this AS6 is that we made an interactive atlas. This is online, and I've put the address there, but you can also Google Interactive Atlas IPCC. And this is for all the different IPCC regions. You can find time series of observations and of projections for, well, every climate variable you can think of, every climate variable assessed in the IPCC report. So there is sea level, but there's also temperature, precipitation, wind. So this is really nice because everyone can look up for their own region how all of these climate variables come together under different scenarios. Specifically for sea level, together with NASA, we've developed a sea level tool where the sea level projections of EA6 are made available. So you can download the data set, but you can also view it online and look at the different processes individually. You can look at different decades, different scenarios, and you can also click on those little blue dots which represent different tide gauge locations around the world. So to wrap up my part of the presentation today, sea level, well, in the IPCC, we've shown that sea level will continue to rise throughout the 21st century and beyond. And we've shown the different processes, and we also show that the rate of sea level rise is strongly determined by the amount of greenhouse gas emissions. Even under strong emission reductions, the sea level rise can still amount to 1 to 3 meters by 2300. So sea level will rise, but it's still we can still have impact on how fast it rises. Yeah, so that ends my part. Thanks all, and many thanks to the chapter scientists and the chapter 9 author team. Now over to Gonéri. And I will stop.
Thank you, Aimée. Okay, I'm starting to share my presentation. You should be able to see it now. So I'm going to report about sea level rise implications in the second assessment, in the second working group of the 6th assessment report. Thank you for your invitation, and thank you, Aimée, for the working group 1 highlights. So within the working group 2 report, we have sea level rise information in basically all chapters, including the regional chapters, but also in the cities chapter and others, which means that it's not strictly straightforward to find sea level information in the reports. However, you can find it in the summary for policymaker, also in a cross-chapter paper number 2, which is about cities and settlement by the seas. And finally, there is a cross-chapter box in the chapter 3 on ocean and coastal ecosystem, which is specifically on sea level rise implications. So within working group 2, you can see my 269 co-authors here and our co-chairs and CLAs. We reviewed 34,000 studies over 4 years. We received 60,000 comments. And you can see that there is overall, let's say, a relatively good balance between men and women, and also between North and South co-authors. So we start with recognizing in this report that coastal zones are constantly evolving due to natural processes, due to coastal interventions, and due to climate change. And basically, we have this nice illustration from a paper by Sally Brown in 2014. She gives the other drivers which have shaped the coast over the past century. So population changes, economic development, land use changes, water management, and sometimes subsidence, and also the climate drivers which are emerging since a few decades, including the rising temperature, which change, for example, the fisheries, the fishing activities at the coast, but also, of course, sea level rise. And we know that these climate change drivers are becoming more and more important. They will become major driver of change over the coming century. And but there is not a single future for the coast. There could be possibly some abandonment or maybe relocation in some cases. There could be maybe some development of coastal ecosystems, so restoring dunes or wetlands, so that it makes a buffer between the sea and the coast, and it offers some protection against storms. And there could be also, especially in big cities, the development and the rising of coastal defenses so that protection levels are guaranteed. But what we can say is that Working Group 2 considers the most recent sea level projections that are made available by Working Group 1. So this is shown, for example, here in this figure of the Mediterranean cross chapter paper in the Nile Delta. So you can see in blue the area which are below high tide levels today. So this is the upper left figure. In 2100, for 3 different assumptions. So one is a low emission scenario. So the median is 43 centimeters in 2100 in this specific location. And you can see that the low-lying area has not changed much between today and this low emission scenario, but still it has expanded a bit in the eastern side because of subsidence. And this rise of sea level means that the area exposed to, let's say, flooding has not changed a lot, but there is a need for protection, accommodation, or maybe some relocation to accommodate these new sea levels. You see also that the population density has changed in this case. So we follow the socio-economic pathway number 1, which is a socio-economic pathway where the population go more in the cities, but there is a general drop of population in the Egypt in this scenario. So you see that the population densities are less than today, for example. In 2100 with SSP 5/8.5, so this is a very high emission scenario, which results in 75 centimeters of sea level rise in 2100. You see that the area exposed has extended a bit, but not so much, and that the cities are more densely populated. And finally, there is a scenario with 1.7 meters of sea level rise, which considers additional ice sheet melting. So the low likelihood, high impact pathway, which is mentioned in Working Group 1. And you see that the exposed area has extended a lot due to both subsidence and the sea level rise. So the question here, of course, is it may be very unlikely to reach such a high sea level rise in 2100. But on the other hand, you may, given that sea levels are committed to rise for centuries, you may frame these questions differently and ask, when will sea level exceed 1.7 meters in this area? It may be in 100 years, it may be in several centuries, but it will happen probably, and there will be adaptation for needs for this specific case. So in the summary for policymakers, you can see that early impacts of accelerating sea level rise are being observed. And you can see this in this column here, which is highlighted in red. These are the flood storm-induced damages in coastal area. But you can see that the confidence varies depending on the regional context. And for example, there is a relatively high confidence, that flood storm-induced damage have increased in coastal area in Asia, Australasia, and the US, in North America. And lower confidence in Europe. And this is probably due to regional context. And especially in Europe, we have usually high standards. And the only place where we have good evidences that sea level has driven coastal risks, has increased coastal flooding is really Venice. And in other areas, we are limited by probably lack of data, but also by the fact that natural processes still play a major role in shaping coast and in driving current risks. So we see that sea level rise risks are about to emerge from natural variabilities, and there are certainly some sites which are early responders where we observe already a high tide, chronic flooding, and rising water tables. But in the majority of the cases, this is more something that will increase in the future. So you see an example here of high tide levels in the US, where basically the colleagues from NOAA are concerned about transport infrastructure and ports being less available due to sea level rise. We see also that in the future, the increased flooding during storms is projected to increase. And we have example of existing storm today, the Cynthia storm in 2010 in France has flooded this area, and there was something like 50 people dying in their houses. But the key driver of this was really a particular track of the storm and not specifically sea level rise. And finally, maybe further in the future, we will experience increased salinization, increased erosion, and permanent flooding. And regarding erosion, we acknowledge that there are early responders, especially in Tasmania, in small islands in the Pacific, which are already facing erosion, probably due to sea level rise. But this does not correspond to the majority of sites worldwide. And here you have an example in Aquitaine, for example, where you see the erosion after a sequence of storms. So you see that there are huge amounts of sands that have been removed after this sequence of storms of 2013, 2014. And of course, sea level rise on the top of that can hardly be observed because of the huge amounts that are removed by natural variability. So what can be chronic flooding at high tide? This is an example in French Guiana, where you see a road which is flooded due to basically high water levels, which in this case are due to northern swells. And you see that this is not a disaster. The guy on his bicycle can still manage to travel on this road. But on the long term, this type of event is projected to occur more and more in many places and to disturb activities in harbors, in coastal settlements like here. And this is, let's say, the most urgent concern that is raised in this report. In the case of Venice, for example, you can frame the Alta Acqua story like chronic flooding events. So you see on these figures that the number of high tide events has risen consistently with sea level rise, which in this case are due to both subsidence and climate change. And you can see that to prevent further chronic flooding, the Italians have built a barrier, which is the Moss barrier, which prevents the cities to be flooded during a high tide event from the Adriatic Sea. But how long will this barrier be sufficient? It will depend on future sea level rise. You can see that with 50 centimeters of sea level rise, the barrier needs to be closed during 2 months, which means that there will be severe limitation of ship traffic and the lagoon water exchanges, and so a large impact on the lagoon ecosystems. And this could occur under a high emission scenario during the second half of this century. So we see also that in these figures that the Italians have started to discuss a potential solution to this increased frequency of chronic flooding in the 1960s. They had the design of this barrier in the 1980s, and the barrier is operational since 2020 only, which means that adaptation even to these chronic events requires a lot of time. And so we need to consider that adaptation requires a lot of time when we speak about the urgency of adapting to sea level rise. So there is a topic on coastal ecosystem and the impact of climate of sea level rise on this coastal ecosystem. And we recognize that coastal ecosystem can migrate landward or grow vertically. So this is the case, for example, for corals. You can see here coral reefs. However, these coral reefs are also affected by ocean warming and other drivers like acidification of the ocean. And basically, they are becoming, they are bleaching and they are becoming degraded because of these changes. And so the capacity to migrate landward or to grow vertically of this coastal ecosystem is limited due to climate change. And for corals, we have the statement in chapter 3 that the effectiveness of conservation efforts to sustain living coral area, coral diversity and reef growth is limited for the majority of the world reefs with 1.5 degree of warming. And there is high confidence there. So as shown by Aimée, there is a K risk, which is the flooding during extreme events. And so you can see that during extreme events, on the top of mean sea levels or at tidal levels, sea level is rising due to winds, due to reduced atmospheric pressure, due to wave breaking. And so this is a simulation, for example, here on sandy Lido, southern France, of a storm that occurred in the 80s. And you see that with 30 centimeters of sea level rise, sea level with the same forcing, the same storm forcing, almost flood the entire Lido. And this is even worse for 1 meter of sea level rise. So in this case, with such an event, you may even question the habitability of this Lido, and there would probably be a lot of questions about relocation. At centennial timescales, projected sea level rise represent an existential threat for island nations, for low-lying coastal zones, and the community infrastructure and cultural heritage therein. And so this is shown here in the Mediterranean region with all the UNESCO World Heritage Sites which are threatened by sea level rise during the 21st century. And this is also shown here with these burning embers. So burning embers show how risks are growing with a degree of global warming levels. And this is here for coastal risks as we reach 2 degrees of climate change. So this may be, maybe, I don't know, in 2050. But once you exceed 2 degrees of global warming, you are committed to sea level rise for centuries. This is what Aimée showed. And it means also that you will exceed, you will flood some areas. There will be permanent flooding in some area. And this is represented here with these very high risks, which shows that basically in this case, adaptation means relocation in many places. And there are several issues which are, let's say, relevant for today's decisions. Also, they will happen only in centuries from now. And here, this is exemplified with the question of coastal landfills, which are becoming, today we see some places where landfills are eroded. And we see that this is a management problem which is not simple. You may remove the landfill, you may protect them or confine them. There is a paper by Robert Nichols on this last year under the Protect project. And this issue, of course, needs to be considered now in order to avoid lock-ins in the future. So I'm going to speak a bit about observed and future adaptation. You can see here the barrier of the Thames estuary, which is one of the examples where people have thought about how to adapt this infrastructure with rising sea levels up to 3 meters of sea level rise. So adaptation has been framed in the special report on ocean and coastal systems as this way. So we could avoid future coastal impact by preventing new developments in exposed coastal locations. And for existing infrastructure, we could imagine no response, so flooding of the area and abandonment. We could imagine protection with dikes or with coastal ecosystem like here. We could imagine planned relocation or retreat, even advance like this is done in the Maldives, or accommodation in area not exposed to waves, like here you can see these raised houses. And this is something, for example, you see in French Polynesia, there are some houses which are built this way to prevent flooding during storms or cyclones in this case. We recognize that coastal adaptation is progressing, and this is shown here on the left by this sea level scenario, which are shown in blue. You see that in France, we have a 60 centimeter sea level scenario used to prevent further urbanization in coastal area. And you see that in the Netherlands and UK, there are not only, let's say, reasonable sea level scenario, but also quite extreme sea level scenario, what they call H++ or high-end sea level scenario, which are used for a stress test on coastal infrastructure. And you see on the right that adaptation is progressing. This is a dark blue color here, but adaptation is progressing mainly in the area of preparation, like laws and things like this, assessing risks, identifying options, but it's lagging behind in terms of implementation. And on the area of monitoring and evaluation of adaptation, this is contrasted. This is only about the national plans of adaptation in Europe, and it tells nothing about regional plans and, let's say, municipality plans. The report says that there are many measures, many adaptation measures that are available, but their feasibility and effectiveness vary. And so you can see on the right adaptation measures to flooding. And you can see that, for example, planned relocation, so retreat, is very effective. If you remove this building, there is no risks, but it's poorly accepted. So the socio-cultural feasibility can be debated. And here you have an area where dikes were removed, so it can be framed as an ecosystem-based adaptation measure. And you see that it's in terms of feasibility, it's feasibility economically, technologically, etc. But the effectiveness, especially for very high rates of sea level rise, is not demonstrated. So you may wonder if it is let's say an adaptation solution which is adapted for very high emission scenario or for high end sea level rise. You can see also that this is a figure from the summary for policymakers. Here you have a lot of adaptation measures, and these adaptation measures are not all relevant to coastal area, but those in red are relevant to coastal area. And you see that they have co-benefits, or sometimes there are trade-offs. And for example, coastal defenses and hardening, one trade-off is that it can damage coastal ecosystem. But there are other benefits, which you can see with plus here, and which relate to the different sustainable development goals. So these are the goals which have been agreed by UN countries to reach by 2030. And these are, for example, reducing hunger, having good health and well-being, quality education, things like this. And you see that overall, the adaptation measures that are identified by Working Group 2 have co-benefits. So you see a lot of plus, and including for coastal ecosystem, but of course not all. And we have to manage these trade-offs. We'll skip this one. In the summary for policymaker, it is recognized that sea level rise poses a distinctive and severe adaptation challenge, and that responses to sea level rise are more effective if they are combined, sequenced, and planned well ahead. So this is shown in the report with this adaptation pathway, where you can see which measure you can use, for example, for a low global warming level, for medium global warming level, or high global warming level. In practice, this arrow here would be time, actually. And you see that, for example, with very high global warming levels, at some point, in some very low-lying area, there would be probably no option but relocation. And other effective approaches towards sea level rise include the alignment of the measures with socio-cultural values and development priorities, and the inclusive community engagement processes that can be put in place. So this is an encouragement to have more social studies on sea level rise and to take into account the priorities locally and the perception of people. The report also says that adaptation capacity and governance to manage sea level rise risks typically require decades to implement and institutionalize. And so there are many examples of this in the report on New Zealand and Australia, but we have also some practice. For example, in France, we know that the coastal adaptation measures are improving since 20 years, but we are still not covering all the issues related to sea level rise. And finally, this message that the future of a coast depends on immediate mitigation and adaptation action. So mitigation to keep sea level rise rates at 4 millimeters per year and preserve resilient ecosystem, and adaptation in particular to coastal flooding, in order to, in particular, taking into account that adaptation requires a lot of time. And so here, for example, you have indicative time for planning and implementation, and you may debate whether, for example, planned relocation requires 40 years or 35, but these are order of magnitude. But in any case, it requires a lot of time. And we also recognize that while implementing climate policies, we also have the opportunity to create more resilient coastal environments and to restore coastal ecosystems. So just taking a broader perspective, this report makes the point that there is an increasing urgency. The word urgent is used several times in the summary for policymaker, and that starting today, every action, every decision maker. And so we could have followed this pathway here to reach climate resilient development just after the Paris Agreement, but we are still not on the right track, we could say. But we can say that in the future, even if we have future climatic and non-climatic shocks, any delay in reducing greenhouse gas emission will increase risks, and any delay in adaptation will increase the impacts of climate change. And so this report makes the point that the window of opportunity to adapt to climate change and to reduce climate change and to achieve the sustainable development goals is reducing, and starting today, every action, every decision matters. Thank you for your attention.
Thank you, Gonéri. Thank you, Aimée. There has been a long debate on the chat. I don't know if we should consider it as concluded or not. Maybe some people that take part of the debate want to summarize or ask more or not. Please jump in. So I suppose that it's self-contained. Is there any questions in the attendance? Please do not hesitate to jump in. Then I have one. Michael, please.
Yeah, thanks both for very interesting presentations. I have a question to both of you. So you can decide amongst you who is going to answer it. How do you see the future of the IPCC reports? And I leave this question open, and I do that deliberately.
I see Gerhard Kriner in the room, and I think he knows much more than me about that.
No, I don't know more than you. Sorry. I mean, I'm not more authorized than anyone else to talk about the future of the IPCC report. So I would send the ball back to Aimée and Gonéri.
So I will start maybe something. I think that during this process, we had the COVID, and a lot of conferences were changed into virtual conferences. And I think this is something that will become standard actually, because it's not well accepted by many people that IPCC travels a lot. IPCC people travels a lot with huge emissions in terms of flying, and then write a report saying that we need to reduce emissions if we want to achieve the sustainable development goals. So I think this is something that will continue in the future. Then it's really a detail. I think you are asking what should the seventh assessment report do, given that in 7 years from now, this window of opportunity to achieve the sustainable development goals may be closed actually. I think there will be always a need to report about science, about what is the status, what are still the opportunities. There will be always opportunities. We will have maybe lost a lot of things. Maybe if we follow a high emission pathway, we will lose basically a lot of the present day coral cover, but there will be other assets to save. And I think the science will be essential to tell everyone, the decision makers, how we do that. That said, I'm not sure I want to participate to a report telling that we are following again a pathway with a lot of damages and losses actually.
Aimée, you want to complement?
Yeah, it's difficult because I think there's still a lot of science happening and a lot of new interesting things happening in climate science. So in that sense, we would deserve, I think, a new IPCC report. The question is that new science gonna do any more convincing than the current report? I mean, how can it be more convincing? There's almost no way to be more convincing. So that's a bit the depressing side of the whole story, is that there's been 6 assessment reports, and we're still, well, maybe we're now slowly heading the right way, but it's still not really all sunshine and roses. So I'm not sure. I guess there's still some debate to be had on whether a 7th assessment report, and in what form, I would say, would be the most useful. And I'm not sure yet.
Robert, you want to jump in or move on another subject?
This is the same subject, actually, because I think, my observation would be probably working group 2, it becomes more of a working group 2 and working group 3 assessment. Working group 1 is sort of done, not done, but it's, as you say, it's fairly mature. And working group 2 and working group 3 is what we do about the problem. So I suppose that would be my observation. That's a response to you. I have a question, which is about the process. Because what struck me in listening to Gonéry's comments about the literature you assessed was the sheer scale. It's I did the AR4, and I was the CLA then, and we assessed the literature that was much, much smaller in 2007. It was still extraordinarily hard to do, and it completely filled my life for a year or so, a year or two, really. How could AR7 cope with the volume of knowledge? I mean, I just think the process has to evolve, surely, just to cope with how science and assessments are changing.
Thank you, Robert. Yes. So I think the point is that first, for the working group 2, we are supported by almost 700 contributing authors. So we had a lot of support to compile the huge literature. And you are right, there is a huge literature on adaptation, of course, and on adaptation to sea level rise. And this was complexified by the fact that there is no coastal chapter in the working group 2. There is just this cross-chapter box, plus these cross-chapter papers on coastal settlement and cities. And the information about sea level adaptation is everywhere in the reports. I think there is a danger in having this solution that you basically cannot include a lot of the literature which is based on local studies, but which is still very relevant for policymakers. For example, I don't know, all the ecosystem-based adaptation literature is usually done at local sites, actually, the efficiency and feasibility assessments. So maybe there is one point which is behind this feasibility and effectiveness assessment table that you see in the report. There are supplementary materials of the reports, and they aggregate a lot of literature. Then how can we manage this literature? I think, yes, as you say, it's a lot of work, and we were supported by many people. And the 7 assessment reports, I don't know how they can do. I think there is a need for, let's say, review papers done by the scientists, so that there is an intermediate between all the literature done on adaptation on specific topics and the IPCC report. And without that, I think it will be very difficult to manage, as you say.
Gerard, is your answer in the chat a joke, or are you working on a neural network to make the compilation?
It's not really serious, but I mean, maybe it's getting to a scale where it's really getting difficult, let's be honest. We have more and more papers. The reports get longer and longer, it's really getting really difficult to manage. So it's partly a joke actually, but maybe not that much. I don't know.
Other comments or questions? We are close to the 1 hour schedule. You anticipate?
I would say, Robert says, Hall must have a role in helping authors. And yes, and when you make comments in the report as a reviewer, it's extremely useful actually, because we cannot cover all the topics, and making comments is very useful. And I think this maybe this process to have to make review papers, it is also very helpful. When you have a very good review paper on a specific adaptation topic, it's easier then to identify the literature and interpret the support from contributing authors, for example.
Robert?
Well, I mean, sorry to monopolize the conversation, but I think it's interesting that this idea of review papers is an interesting one, Gonéri, because although it's a change to the process, because what you would need to do, the governments would probably have to agree to commission 20 review papers. I don't know exactly. I mean, the numbers are unknown. Commission a small set of review papers well before the assessment, and then so it makes the process more complex. But in many ways, it probably makes it more doable and more representative of the literature. So yeah, I'm just thinking out loud, but I think it's quite a change to do that, but maybe not a bad idea. Thank you.
The only disadvantage would be that you'd be even further behind the literature, of course, because we have already a literature cutoff date. And if you add a review paper stage in front of that, then all literature will be 2 years old by the time you have the IPCC report. So yeah, that's maybe a bit of a problem, but otherwise, well, maybe we should have review paper type rather than these big assessment reports. Maybe it should be split up more or something, and more often, so that it's a less big chunk. Because now, for instance, in chapter 9, we mainly focused on the literature since the special report on the climate and ocean, on the cryosphere and ocean. So that was only about 2 years old by the time AR6 was published. So we had a smaller body of literature to look at. It was still considerable. But yeah, if you have these 7-year chunks, then it gets really large and hard to manage, I would say, yeah.
Okay. So except if there is a urgent and pressing last questions or comments, I'm going to close this webinar. And thanks again, Aimée and Gonéri, for your talk. I wish you a great afternoon all, and see you sometime somewhere in the real life. Goodbye.
Thank you. Bye-bye.
Thanks. Bye-bye.